Okay, class, Tom Simmons here with another installment of Economics with Tully. This particular video is going to make the assumption that you have seen all of the previous videos in the series. It makes the assumption that you understand how to construct a graph, makes the assumption that you know what market demand means. I will review briefly how we plot the demand curve, briefly how we derive the marginal revenue curve, and then we will plot average cost and marginal cost on top of that, and you will have a graph that has all sorts of lines. And if you're like many students, it will be very, very easy to get lost in a graph of lines. And the point of this particular video is to help you step by step not only construct the graph, which is the easy part, but to understand what it means, to interpret it, to analyze it, to read it. When we're looking at profit maximization graphs, there are two forces that are coming into clash here. On the one side, are the consumers, what they believe about the product, what they are willing to spend on a product, how much of a product they are willing to purchase at a given price. That is the demand function. That's the first thing we're going to graph. So I've made the assumption here that maybe we've looked at our records. We have looked at our regular sales over the course of a few weeks, and we found two things. Let's pretend that this is the profit maximization graph for bird food, okay, wild bird seed. And we found that when we priced one of these large bags of bird seed at $14, that we sold 3. When we put them on sale at $10, we sold 5. That gives us demand information. That tells us about consumers, how consumers react to price changes. There's demand. So we plot those 2 points. At a price of $14, remember, price is always on the vertical axis. Quantity of 3, we've got a point right there. And at a price of 10, we have a quantity of 5 right there. And most of the time, those aren't very dark, most of the time, you're not going to have, in the real world, some textbook telling you here's a demand curve for your product. What you will have is a set of data like that. The experience of what happened when you put something on sale and when you sold it at the regular price. From there you derive your demand curve. We will make the assumption it is a linear demand curve. It maintains a constant slope throughout the length of the demand curve. So when we connect these points, and I'm using green to indicate customers, consumers, which translates into revenue coming into your store. This is one of those 2 independent forces. If those are the 2 points and we connect them, you can see the slope is 1 over 1. We're going to have a constant slope, so we're going to extend that demand curve the entire breadth and height of our graph until we intersect both the y and the x-axes, and we have a complete demand curve with a constant linear slope of 1 over 1. There's demand. Of the 4 curves we need in order to do a profit maximization graph, the first one is demand. Boom. You've got the information. You plot it. You extend it linearly. You're done. The second curve we need is the marginal revenue curve. Well, the marginal revenue curve asks the question, if we lower the price just a little bit, or if we make one more, how much more money will we take in for that one additional unit? We don't graph that by plotting points and looking at a table. We graph that by deriving it from the existing demand curve. And if you recall, there are patterns here, all right? And the pattern is that the marginal revenue curve always meets the demand curve where it intersects the y-axis. And the marginal revenue curve always intersects the x-axis at a point halfway between 0, I should have put the 0 in there, 0, and wherever it is the demand curve hits the x-axis. So since it hits at 10, we know it's going to hit the x-axis at 5. And the slope of the marginal revenue curve will always be exactly twice that of the demand curve. So if the demand curve was 1 over 1, or 1 line down, 1 line over, then the marginal revenue curve is going to be 2 lines down and 1 over. So we can easily plot those points, connect them, and now we have marginal revenue. Those two curves represent consumer behavior and give us information about how they react to prices. And again, this assumes that you've looked at these concepts previous to this video. That's one side of the equation. The other side of the equation is cost. The cost that you as a business incur by providing different amounts of the good. And the two curves that are most important to us for this purpose are the average cost, usually called the average total cost, and the marginal cost of making this product. The average cost and the marginal cost curves will follow patterns just like these two curves follow patterns. The cost curves are not linear. They're not lines. They are real curves. Because what happens is, as you make more and more of a good, the cost per good begins to fall. But at some point, due to the law of diminishing marginal returns, at some point, as you make more of that good, your cost per good actually begins to increase. Okay? It doesn't go down forever. So, you complete a cost table in order to get the figures you need to plot for your average cost curve and your marginal cost curve. So, we're going to, again, since I'm focusing on how to interpret a completed graph, we're going to assume that you've made your cost table and then you've taken the quantity and plotted it against average cost, and by plotting those points, you've come up with a curve that looks something like this. And notice I always do cost curves in red, because that's money going out. And the average cost of producing a good, as I said, will always follow this parabola, this curve. Your cost per unit goes down to a point, and then your cost will begin to rise again. That's average cost. Marginal cost asks the question, how much will it cost me to make one more of this good? And again, we plot that by plotting quantity against the marginal cost figures from our cost table. So, assuming that I've done that, I've completed my cost table, I've plotted those points, I'm now connecting the dots, and I'm going to add the marginal cost curve to this graph. Okay, you've now got 4 lines. You've got 2 lines that give you information about consumers, demand and marginal revenue. And that also gives you information about money coming in. That's why they're green. You've got two more lines that represent cost. That's your money going out, what it costs you to make this good or to provide this good. And that's the average cost curve and the marginal cost curve. Both of those cost curves will always be U-shaped. And you can always tell which is which because the marginal cost curve always goes deeper and always crosses the average cost curve at the bottom of the average cost curve. So that means this has to be average cost, this has to be marginal cost. Think of it this way, in case this is a concept that's confusing you. You have average test grades, and then you have the marginal test grade, which would be the next grade you get. If your average of all your tests was an 80, and you got a 90 on your next test, the marginal test, the very next test, what would that do to your average? It would pull it up. Would it pull it up all the way to 90? No, it would pull it up something less than 90. Think of the cost curves as test grades. There's your average grade. If on your marginal test, your next test, you scored higher than your normal average, it begins to pull the average up, but not as high as that last test. That's another way to think of it. So now you've got your four curves drawn. Once they're drawn, once they're plotted correctly, now is the time to analyze it. What does this mean? A couple of things to keep in mind. Marginal curves give you quantity information, and that's all they give you. Your marginal curves give you information about the quantity at which you should produce, and that is the only information those two curves give you. So the first thing you're going to do is find the point where marginal revenue crosses or intersects marginal cost. So make sure you identify your lines correctly. This is the marginal revenue curve. This is the marginal cost curve. The place where they intersect is right here. The reason this is important is because if you move anywhere in this direction on the graph, anywhere along the quantity axis, it means the marginal cost, the cost of making one more unit, is higher than the money you can expect to receive by selling one more unit. Why in the world would you sell something at $4 if you know it's going to cost you $5 to make it? Stop. You're making too much. That's why this is a very critical point. Now, what I recommend you do, and I'll use a color different than red or green, is to draw a dotted line perfectly vertically through that point, because that's telling you the quantity at which you want to operate to maximize profit. So I'm drawing this vertical blue line up and down all the way through the graph just to give my eyes a place to look. So the first thing we have determined by looking at where marginal revenue and marginal cost cross is that the quantity of production that will maximize profit, given our current cost structure and given the current behavior patterns of our consumers, is 4. We want to make or provide 4 of these big bags of birdseed. I think that's what we said we were doing, birdseed. That's the quantity that's going to maximize profit. There's no sense in making more, providing more, or using more shelf space than that. Because providing more results in a cost per unit that is greater than the amount of money we can expect to take in per unit. Why bother? 4 is key. Now, a note on quantity. Life is not always nice and tidy. And sometimes, if you graph this, you'll find that these curves will not cross precisely on a round unit, on 4. Maybe they'll cross like at 4.7 or 3.8. You can't make a fraction of a product. You can't sell 7/8 of a car. If you're a factory that makes fabric, and fabric comes in, say, 100 yards of fabric on a bolt, you don't stop the press at when you get to 85.5 feet and say, okay, we got to stop right here. So whenever you have a graph and the marginal curves appear to intersect at a non-round number, you can't use the fraction. Adjust it, move it to the nearest whole number, because you can't sell a fraction of a product. In this case, I made it easy for you. We're exactly at 4. Now, once we've determined that 4 is the quantity that maximizes profit, you are done with your marginal cost and marginal revenue curve. You don't ever need to look at them again. A very common error, and I'm afraid to tell you this. It's kind of like Dad saying, do not eat that cookie that I put on the counter, because then all you want to do is eat the cookie I put on the counter. But I'm going to do it anyway. Once you've found where those two curves cross, do not let your eyes drift to the left. Do not say, oh, well, this is an important point. Let me look over here. Stop! Slap your hand. Don't do it. Marginal curves give you quantity information and nothing else. Don't ever, ever, ever start looking to that axis from that point. Only quantity. Conversely, we have 2 curves left we have not read. Those curves are going to give you dollar information and not quantity information. So, we know we're going to produce 4 bags of birdseed. Well, what should we price 4 bags of birdseed at? If this was the very first lesson, you would have, in demand, you would instantly know how to do this. But because we got all these lines here, students get a little bowled over like, oh, I don't know, how do I find that? If you want to sell 4 bags of this birdseed, how do you figure out what the right price is? Well, you can't force your customers to do anything. You have to look at your customers' behavior. And we get that from the demand curve. And the demand curve tells us that at a quantity of 4, you want to sell 4? Your demand curve tells us $12 is the price. And I'm going to make another dotted line, because this is a sight line for my eye, over to 12. That's the price. One way to look at it is at a price of 12, you will sell 4. How many do we want to sell? 4, because that's the quantity that's going to maximize profit. So whether you say at a price of 12, I'll sell 4, or if I want to sell 4, I bounce off my demand curve and I'll price it at 12, it works both ways. We now know that we're going to make 4 bags of birdseed and we're going to price them at $12 each. Now, the next step is to ask ourselves, well, if we do that, what's it going to cost us? because we've got to get this birdseed. We've got to assemble it. We've got to put it in bags. We've got to get it out on the shelf. There's one curve we have not looked at yet, and that's the average cost curve. That's this one right here. And it's really very simple. We simply say, if we're making 4, what is the cost per item, per bag of seed? Well, at a quantity of 4, it intersects the average cost right there. It's going to cost us $8 per bag of birdseed. You now have all the information you need to determine what profit you can expect. Given your customer's behavior, green lines, given what it costs you to provide this good, red lines, you should make 4, you should charge $12 per bag, and it's going to cost you $8 per bag. What's your total expected maximum profit? The price you charge minus what it costs you to make it times the number you're going to sell. 12 minus 8 would be a profit of $4 per bag times 4 bags. You can expect to make a profit of $16 on this particular product by making 4, providing 4, selling them at 12. And for those of you who like graphs, this box in this dotted area is a graphical representation of your profit. It's the price minus the cost up to a quantity of 4. That's profit. If you go through this step by step, it's really not that hard, but it is very easy to get lost in lines. It's very easy to make the mistake of, once you find this point, to look that way. Stop. Use your marginal curves to get a quantity. Use your average cost to get cost. Use your demand to get price. And then think through it logically. Of course, my price minus my cost is my profit. How many am I going to sell? Multiply profit by the number I'm going to sell. Now, when we did this, it is possible that the average cost curve, even though I drew it here, might have been somewhere up here. So what would that tell you? That would tell you that the best case scenario would be a loss because your cost would be higher than the price you'd be able to charge for that good. And that happens. Happens in many businesses during certain seasons. Many businesses actually run at a loss right up until Black Friday, the day after Thanksgiving. And then they begin running a profit from that point forward. So it is possible to run at a loss. Now, what can you do with a situation like that, or a situation where, well, gee, $16 is not a heck of a lot to make for all the trouble I feel I'm going through? Well, one, you work on lowering your costs. The costs, the red line, are within your control. You find a cheaper supplier. You find a more efficient way to provide the good. That's up to you. Or you find a way to shift demand for that good. And that might be through a marketing campaign of some type. So this is all short run, because in the long run you can change your cost structure. And in the long run, consumer behavior will change based on any changes in determinants. But this is how, when you have information in the here and now, you can figure out what's best. Once you start saying, well, why don't I just put a whole bunch more out on the shelf? More is not better. Because the cost of providing another unit begins to exceed the revenue you can expect to take in for that good. And you may say to yourself, well, I don't get that, because if I'm charging $12 for a bag of birdseed, why don't I put 10 more out? Because then I'll get all that additional money? No. The demand curve tells you what consumers are willing and able to spend on that product at different price levels. And you can put 10 bags of birdseed out on the shelf, but the demand curve tells you the consumer behavior is such that at $12 they buy 4. You're going to have 6 bags of birdseed go rot on you. The only way to get rid of it would be to put it on sale to such an extent that you'd lose money doing it. And that is what many, many businesses do. They think more must be better. You've got to really, rein in that tendency to think, oh, we sold 4, we sold out. Let's have twice as much next time. Not necessarily. So, this is how you read your curves. This is how you read your graphs. It is a long process. You've got to figure out what is your demand for the good. You've got to complete cost tables. After you've done all of that, then you construct your graph. You plot your demand curve. You derive your marginal revenue curve from that. You plot your average cost curve. You plot your marginal cost curve. This is not something you just do, real quick, 5 minutes before it's due, because you need to come up with an answer. It takes time. Once you've got it set, now you can interpret your graph. Hopefully that'll help you, and good luck in the graphs that you're going to be doing.